Hello everyone, this is Mr. 13 Things. Picking up in the second video, we're talking about how to do an extrude. What we have right now is a face defined by these points, so that are a distance of 1 away from the origin along each of the axes. These points are defined here, each with a 1 chaser on the bottom, basically, a scale factor, which you'll see is where we put the 1 when we're dealing with basic 3D systems. When we get involved in quaternion mathematics, you'll see that these actually look a little different with the ones put up on top. But that, as it said, the next step is to calculate the normal unit vector by calculating the cross product of any two vectors in the plane. Now, it would seem to be a pretty obvious thing here, or it doesn't make any difference which two vectors, but we'll go ahead and do these two vectors from 0.0 to 0.1 and from 0.0 to 0.2. And those are actually defined as P2 minus P2 minus P1, or P1 minus P0. So we'll do that first as a cross product, and you're going to do that hopefully with some sort of software, but we'll go ahead and show you how to do it here mathematically. And the way you do that is you're going to determine the determinant of this I, J, K, and then the first vector and the second vector. That's going to get you the normal vector. The cross product of any two vectors in a plane is calculated using this mathematics, but it's basically a cross product. So the first vector is P1 minus P0, so this is 1 minus 0 in the X. I'm going to now try to do my whole color thing. Keep that up if I can. So this edge here is from P0 to P1, which is P1 minus P0. So 1 minus 0 is 1 in the I. The J is going to be 0. It's a pain in the butt, but we'll try to keep it up for a while. We're going to go ahead and 1, 0 in the J, and 0, minus 1, and minus 1 in the K. And so we're going to go again and do this. And if you notice, these colors I'm picking are not arbitrary, actually. Standards within CAD systems, as a rule, are red is X, green is Y, and blue is Z. Check it out in your Game Boy console. And if I'm wrong, just post a response. But pretty standard in a system, CAD, SketchUp, AutoCAD, Inventor, to use these three colors. So that's my first vector from 0.0 to 0.1. My second vector is going to be from 0.0 to 0.2, the cross product of any two vectors in a plane. And you could use another one as well, but those are the two we're going to use. So this is going to be 0.2 minus 0.0, and that's going to be 0, 1, and 0. So we'll again go back to here. And then I'm going to check that I did the math right. 0, and back to the, off on the side, what I'm doing is using a color sucker, if you would. 0.0, and this is 1, and then it wasn't 0, it's minus 1. It's minus 1. So you're taking 0.2 minus 0.0. Again, we count often in programming or higher order math, sometimes we start counting at 0. Don't get too confused by that. It's not the most important thing. These numbers are actually, when you think about it, they are more to be thought of as names. So we're back here, and this is 0 minus 1. And now I'm going to check something here, and that's basically the case. And if you think about it, the two vectors we were dealing with, this one and this one is going up in the X by 1. One is going up in the Y by 1, but they're both coming down in the Z by minus 1. So we're going to take the determinant of that matrix, and the way all kinds of different ways to do it. I'm going to go ahead and do the way many people do, and this is I'm going to go ahead and just take I and J out here. I won't switch the colors. I am going to then start repeating again 1 and 0. And 0 and 1. I'm going to take these three minus these three, right? And you're going to see that this is going to get us a vector. So plus is along those diagonals, minus along those diagonals. So do the same for these three minus these three, and then these three minus these three. All right, so here's the i's. The i's, this 0 falls out, and the i's is going to be minus 1i, but a minus of that, so it's going to be 1i. Back to the color thing. So it's going to be 1 in the I direction. Apologize for the... And again, very quickly, 1 I, or 1 in the X direction, plus, I'm trying to do the color thing, this can get kind of old. Okay, plus, what in the J? Well, the J you have minus a 0 there, so that falls out. And in the J you have, again, minus, but then a minus, so it's plus 1J, right? Plus, and now you're going to do the K's, which means you're going to change color again. So eventually you want to train out your brain from having to use the colors. So, but we'll keep doing it here. This is minus K, and that's minus K. Well, let's double check that that's right. So that's minus K. Now, when I look at that, I'm looking that I have a, we're going to talk about what that means, because the normal vector should be, in my brain, being positive in the X, positive in the Y, and positive in the Z. So if I look K1 minus 1, I multiply those out positively, I get still a minus K. So I want to double check that my cross product, that I've defined things right. So let's double check now that we did this 0, and here's the problem right here. You see that 1 here? That should be plus 1, and that should be plus K, plus 1K. So once again, until students are used to doing the math by hand, they should be learning to do it by a calculator as well, and I will do that on a separate video. So we have the normal here, which is 1i plus 1j plus 1k. And very quickly students can kind of learn, I would hope that they can learn how to calculate what that looks like in a formula for mathematics. This is a plane, but they basically right now they have something they can understand in 3D space. Now what they also need to understand is that this vector, even though it has 1, 1, and 1, its length is much more than 1. Its length is, you know, basically the square root of 1 squared plus 1 squared plus 1 squared, or the square root of 3. So the normal vector, so the unit vector, is equal to 1 over the square root of 3i plus 1 over the square root of 3j plus 1 over the square root of 3k. That j should not be there. Right? So what we've done here in this 8 minutes, right, is by hand we've calculated the normal to this vector. So I'm going to go through it again. And it turned out to be the normal unit vector is 1 over the square root of 3, which of course math teachers hate. So right away you might go the square root of 3 over 3 plus the square root of 3 over 3 plus the square root of 3 over 3 I, j, k. But also informing students that in some ways, for some points in time, it's fine to carry around 1 over the square root of 3, because this one particularly becomes pretty easily an easy pattern. 1 over the square root of 5 is the square root of 5 over 5. 1 over the square root of 2 is the square root of 2 over 2. But because you're maybe trying to get it lined up a little bit in your cross-silo rivalries, you might want to show them that these are the same. Realistically, you'd be dealing with numbers when you end with this. So 1 over the square root of 3, the square root of 3 is about 1.7 something, so you would come up with some sort of different value here. All right, so to review, this was the calculate the normal unit vector. We did it by taking any two vectors in the plane, and that was point 1 from point 0 to point 1, which was this value, 0, 1, 0, minus 1. And also calculating the second vector, which was from point 0 to point 2, which is 0, 1, minus 1. You checked it by seeing that the first vector was going up by 1 in the x and down by 1 in the z, and the second vector was going by up by 1 in the x and down by 1 in the z. You then calculated the determinant, and realistically you would also want to do this with Wolfram Alpha or with a calculator or whatever you're going to choose to do. Lots of videos on that, but the determinant of this matrix, which is described as I, J, K across the top, the components of the first vector and the components of the second vector, gets you a vector that is longer than length 1. There's actually tells you something about the area of this triangle. I think 1/2 of this magnitude is the area or something like that. You can figure that out. And then you normalized it by dividing the unit or the normal vector by its length, which was the square root of 3, and you came up with this as the distance of the unit vector that is normal to this plane. So the next step is going to be to decide how much you want to extrude that out, and we're going to, in this case, extrude it out a distance of 3 in our next video, and add that to each of these points, and you have done your extrusion. So we have calculated the normal unit vector. The next thing is to scale that normal up to your extrude distance. We'll do that right now to finish out this video. We're going to go 3 up. Therefore, our vector, let's see if I can erase something here, which I'm not going to do. So when we scale it up, it's by 3, it's going to be, we're going to add the square root of 3 over I plus the square root of 3 over j plus the square root of 3 over k to each of our components, and that will get us the second set of points in our extrude distance. Thanks for listening, and tune in for the final one. We'll also do this then in SketchUp and eventually with my daughter's help in Inventor. Thanks for listening.